In this lesson, we are going to solve some more functions by graphing. In particular, we're going to do logarithmic exponential ones and trigonometric ones. So we're going to do equations and we're going to do inequalities, just like we've done for polynomials and for what else? I think we've done some logarithmic ones already, haven't we? No, we've done rational functions. All right, so there's two strategies that we saw for working with the rational functions. One of them is to graph the left side, graph the right side, and the solution is the x-coordinate of the point of intersection. However, we also saw another possibility is to put everything on one side and then see where the x-intercepts are. I won't do them both in every case, but I might do them both in one case or one or two cases so you can see how they compare. If we're dealing with inequalities, then strategy one would be to graph both sides separately and see which side is above in the case of greater or below in the case of less than. And if we put them all on one side for an inequality, then we just look for what's above the x-axis or what's below the x-axis. So let's get right into it. So the first one's pre-graph for us. Find the roots of each equation. So we have log x plus 4 is equal to 1. So if I want to do them graphing each side separately, then this blue graph here, that one there, is the graph of log of x plus 4. And the red graph is just the log of y equals 1. Okay, so what y equals 1 is just a horizontal line, and log of x plus 4, as you can see, is a logarithmic function. It's been shifted 4 units to the left because of that d value of -4. Now we're trying to find the solution, so what we look for is where the 2 points intersect, 2 lines intersect, and that's at the point 6, 1, but the solution is just the x value of that, so the solution is x equals 6. Therefore, x equals 6 is the root of the equation, or the solution to the equation, log x plus 4 equals 1. So that one was done for us. Let's try one on Desmos. So on the one side, let's go to Desmos. So we're going to do two sides separately to start with. So y equals, remember you can find functions over on the right, and so I'm going to do log base 5, and then brackets 2x minus 3. That's the one function, and then the other one is again just a linear one, y equals 1. And so where these two graphs intersect is going to be my solution. And so they intersect at the point 4, 1, and so x equals 4. Oh, sorry, not 1. My bad. I just realized that it should have been a 2 here, so that changes things. So I have to zoom out a bit. And actually, it intersects at 14, too. So same idea, without the typo, though. All right, so 14 is my solution. Maybe just draw a quick little sketch of this just to illustrate. Okay, so we had that vertical asymptote at 1.5. I haven't put a scale on here, but let's assume that's 1.5. So 1, 2, so on. And draw the sketch. something like this. And then we had the other graph, which was a horizontal line at y equals 2. And where the two intersect was at the point 14, 2. So the solution is x equals 14. But as I said, we could have also done method 2. We've seen the two methods before when we did rational functions. The other one was to put everything on the one side and then just see where it's above or below the x-axis. So let's do that as well. So the other possibility is we could have log base 5 x 2x minus 3. Bring the 2 over to the left side, so we have a minus 2 there, equals 0. I can't combine this 3 and this 2 because of order of operations. That 3 is inside the brackets. I'd have to deal with the log first. So these have to stay separated in case you were wondering why we didn't combine that into a minus 5. We can't. But we can certainly graph that and see what we get. And in fact, I can just modify this function here. I'll just put a minus 2 on it. And as you can see, really what happens is just moved everything down. Instead of getting 14, 2, we now have an x-intercept at 14, 0, and 14 is still our solution. Maybe a quick sketch of that one as well. Oops. Try that again. Undo. So it still has the same asymptote at 1.5, but now it's going to be a little bit shifted over to the right. And again, I'll just add the scale myself and say that this is the point 14, 0. Since it's just a sketch, but it's where it crosses the x-axis. It's the x-intercept. So either way, either method gets you the same solution. Take your pick in this case. Okay. Let's look at a logarithmic inequality example. So we've seen for inequalities, we still want to find the point of intersection, or points of intersection, but we're looking for whole ranges of solutions. So again, I could do it either way. I could use method 1 or method 2. In this case, maybe I'll just, if all other things are equal, I like the method where we rearrange and then just look for x-intercepts. Sometimes the other way is easier, so I can't say it's always going to be the case that I want to do that. But in this case, it seems like either one would be fine. So I'm going to go with my preference. So I brought the 1 over, and now I'm simplifying the equation. It simplifies down to just plus 3 in that case, and that's less than or equal to 0. So I'll graph the function, this function here in Desmos, right? Y equals this. See what it looks like, see where it's below the x-axis, and that'll give me my solution. So now I got a double set of brackets there, but I don't think that's going to cause me any problems. All right, here we have our graph, and I'm looking for where it crosses the x-axis, all the way out here at 30. And that's the only chunk for this graph, right? The whole graph is in quadrant 1 or 4, when it crosses over. I want the part where the graph is below the x-axis. So I'm interested in this part from 30 to the right. That's where it's below the x-axis. So that means the x values have to be greater than or equal to 30. And it's or equal to, again, because of that equal sign underneath here. So x must be greater than or equal to 30 for this one. Here's the sketch. Here's the x-intercept. We want this chunk of the graph right here. So we've seen how we can use these two methods for polynomials, for rational functions, for logarithms. We can use them for trig functions as well. Once again, we can do method 1. We can do method 2. I'll just call that make one equation, since we've already talked about it a few times. Find x-intercepts. So those are our two methods. And we're going to do everything the same. We're just working with trig rather than logarithm or rational functions. For trig functions, you often will find that an interval is given, such as 0 to 2 pi, since they do go on forever. Not always, but if you should watch out for intervals if we're dealing with trig functions. So the next one, determine the exact solutions for the trigonometric equation 2 sine x minus 1 equals 0 on the interval 0 to 2 pi. Square brackets are telling us about an interval. So in other words, that's not an ordered pair. Those square brackets are telling us that the interval, we're only interested in starting at 0 on the left and going up to 2 pi on the right. So it's just giving us an interval that we're dealing with. So we can graph this equation on Desmos and see what it looks like. So you could type in, I could go to my keyboard and I could type in sine. That works perfectly well. But I could also go to the functions on the right, and sine's there. So there's a couple ways to get sine as a function. Take your pick. So 2 sine x minus 1. One thing I do have to do for using Desmos, which I forgot, and that's why my graph is looking pretty funny, and it's a good chance to talk about it, is we have to change the settings here. Well, actually, I've already done it, but I still have to play with some other things. Your settings may be automatically set to degrees, so go into the settings and first of all make sure it's in radians. So mine is in radians. But as far as the x-axis goes, because we're going up by radians, we want to use pi. So I can actually go into step here, and if you look down the bottom left-ish of my keypad, beside ABC, beside the square root sign, you'll see pi. I can just type pi in there, and I'm telling the Desmos to make my axis go up by fractions of pi. So it's actually just automatically doing it, but if I zoom in a bit, it'll change it for me. So it's going up by pi here. I might want to actually go up by even less than that. Maybe I want to go up by, well, let's try going up by pi over 2. See how that works. I can change it if I need to later. So it's going up by pi over 2 for now. And if that's not good enough, I can still adjust it. So I also want to go from 0 to 2 pi. So again, I I can just do it myself where I find where 2 pi is, or I could go into the settings and tell it in here to go from 0 to 2 pi as far as what I want revealed to me. So again, you've got options. There's the graph. You can see that the maximum is at pi over 2, 1. You can see that the minimum is at 3 pi over 2 and negative 3. That's not what we're looking for, though. What we're looking for are the x-intercepts. The x-intercepts occur at pi over 6 and 5 pi over 6. And those are our exact solutions. So first I'll sketch it. So pi over 6 is here. Maximum was at 1. Came back down at 5 pi over 6, which is there. Minimum at negative 3 pi over 2 and negative 3. I think we hit these points as well. That's pretty much what we had. But what we care about are the x-intercepts. Those are our solutions. So x equals pi over 6, as we saw back on Desmos, and 5 pi over 6. Now, I'll leave it like that. All right, so there's our graph. Y equals 2 sine x minus 1. So there's our function. Okay. Solve 2 cosecant squared x plus cosecant x minus 1 equals 0 on the interval 0 to 2 pi. So again, this is a pretty odd graph. You would have a really hard time, I think, solving this graphically without Desmos, but luckily we don't have to. So typing that in, the related function would be y equals 2 cosecant and I think I can backtrack to add the squared in there, yeah. So I need the squared in right after the cosecant, and then I put the x in. Plus cosecant x, go back to my function here, or again I could just go CSC on the keyboard. Minus 1. Nope, but that has to be outside the brackets. Minus 1 outside brackets. All right, there's our function. The scale still goes from 0 to 2 pi, so we can already see, it's already set up the way we want it. We're trying to see where it crosses, or touches anyway, the x-axis. 3 pi over 2 seems to be the only solution in this case. There's a vertical asymptote at 0, at pi, and at 2 pi. You may remember that on the cosecant graph. This one hasn't been shifted at all. So for my sketch, vertical asymptotes here. And the lowest that this one went was at 2. So if I make my scale 1, 2, 3, 4 like that, then this part comes down as far as 2. This part was the only part that came down and touched the x-axis, and that's my solution. 3 pi over 2. Finally, we're going to do an inequality involving trig functions. Again, my choice, do I want to put everything on one side and just look at the x-axis, or do I want to graph the left and right side separately? I'm going to go with my preference, which is bring everything to the one side. In this case, it just seems easier in this case. If I bring -5 over to the other side, then when I add it, it becomes +5, so I end up with +2 is less than 0. So this is the actual inequality that I'm graphing. And so I'm going to look at 4 cos 2x plus 2, and because it's a less than, I'm going to look for where that graph is below the x-axis. Let's use the keyboard this time so you can see me doing it. +2. All right, so let's just adjust this a little bit so it goes from -4 on the y-axis to +4, which will match our actual graph. Well, actually, that doesn't even fit on our graph. Maybe I'll have to go with a different scale. Let's make it go from -8 to +8, and I'll just make my scale different on our sketch. So there's our graph. My scale is going from -8 to +8 on the y-axis, 0 to 2 pi again on the x-axis. And as far as that sketch goes, so 2, 4, 6, 8, and so on. It started at 0, 6. It went down to pi/2, -2. It went back up to 0, 6. And it oscillated back and forth between those maximum and minimum points. There's our graph, there's our shape. So, first we want to look for the x-intercepts. X-intercepts come at pi/3, 2 pi/3, 4 pi/3, and 5 pi/3. So that's easy enough to remember, which means that they should have actually hit. If my graph was better, I want it to look better. I'm going to fix this one so it actually hits it. 5 pi/3. There we go. So it's going to hit those points. What were they again? They were pi/3, 2, pi, 2, 4, and 5. Okay, so that would be my solution if I was just looking for the x-intercepts for the solutions, but we are looking for, well, actually, now that I've rearranged it, let's look at this one. We are looking for where this graph is below the x-axis. So we're looking for this chunk here that I'm highlighting in blue, and this chunk here that I'm highlighting in blue. So the solution, and there's no equal sign involved in this one, so it would simply be pi/3 is less than x, which is less than 2 pi/3, or 4 pi/3 is less than x, which is less than 5 pi/3. Now, don't get hung up on me using the word or here. You could use the word and. Those are, it is true. It is both of them. It's all of them. When I use the word or, I'm simply saying, hey, it could be this or this or this or this or this, but the solution is all of these things. And that's it.